Allocation Department. I'm at the World Bank in Washington, D.C. So Dr. Lerva is going to present a paper called Liquidity Constraints and Capital Allocation, Evidence from a Selective Trial with Ugandan Farmers. So as usual, please note, let's not interrupt her during the first 10 minutes of her presentation. And afterwards, all your comments and questions are, of course, welcome. You just need to unmute yourselves. Benedetta, the floor is yours. So if you can please share your presentation, we can verify that we can all see it and you can start.
Yes, so on the share button, it says only meeting organizers and presenters can share. So I think somebody might have to give me permission to share.
So Carlos, can you please help her with that? If you are there.
Yes, I mean, I'm going to try.
Y también veo a Carlos Muñoz, que es generalmente
Ya,
la persona
ya la pusimos, ya
que
puede
nos
compartir.
ayuda. Okay, Benedetta, I think you can share your screen now. Sorry.
Perfect. Let me just see. Okay, here we go. Hopefully you're able to see
Yes,
it.
we are able to see it.
Nice. If I change it, do you see it changing?
Yes.
Excellent. Thank you everybody for the patience, and thank you for having me. So thanks so much for inviting me, Corellis, and it's great to be with you today. So I'm looking forward to your comments. The paper that I'm presenting today is very exciting. We've been working on this on the experiment, I would say, for quite some time. And we're now sort of getting ready to hopefully push it out over the summer. And so any comment will be super welcome, and will improve the work that we can do over the summer for this. So this work is joined with my colleagues Conrad Burkardi at the IIS at Stockholm University, Jonathan DeQuitt, who's at Queen Mary, and Stefano Tripodi at Promethea. So I'll start from a graph that is potentially familiar to many of you in the literature, and that is showing the maize yields in the past 40 years, 60 years across a few areas of the world. So you can see highlighted in orange are the maize yields in Africa, and you can see that they've been low and pretty stagnating in the past 60 years. So, and this is even, not when compared to just any country, but when compared to countries that were at very similar levels of yields back in the 1960s, and that since then have doubled or tripled or quadrupled their maize yields. There may be a few reasons and rationales behind why we're seeing this in Africa nowadays. And one of the sort of culprits that is often pointed to is the lack of adoption of fertilizer. And so here I'm showing you the graph for the use of nitrogen on African farms compared to the same set of areas of the world over the same time period, and you can see that it's low and stagnating, so kind of mirroring what we saw for maize yields. And this is not just an issue with nitrogen. If I were to show you phosphate, it would be the same. If I were to show you potash, it would be the same. So we sort of see this pattern in low fertilizer use in Africa pretty consistently across types of chemicals. Now, a way in which policymakers have, thought about how to solve this problem is by introducing subsidies. And subsidies have, in fact, been introduced in different types throughout the years. But what we can see nowadays is that they are definitely, subsidy programs are definitely implemented across the continent. So I can make you examples from Kenya, Tanzania, Rwanda in East Africa, or from Burkina Faso, Mali, Nigeria, in West Africa, or from Zambia, Malawi, in South Africa. It's very spread overall. And these fertilizer subsidies are generally of two types, either universal distributions or more targeted vouchers, with like a sort of, I would say, a recent, more pronounced shift in the voucher subsidies, because voucher subsidies, they can be targeted. You can hand them to the people you want, and they are supposed to be contributing to developing a fertilizer or an input market locally, because in order to redeem the vouchers, farmers have to go to the local agro dealers, shops, or have to stock them. Now, the subsidies constitute both a large share of the budgets in many African countries. And here I have the example from Zambia that uses about 37% of its agricultural budget in 2005 on subsidies. And they also represent a large share of the price. So in Malawi, the subsidy is larger than 60% than the market price. And the Malawi case is maybe one of the most famous across the world in terms of the size of the subsidy program. What I'm going to discuss today is a paper that looks at how markets allocate fertilizers with evidence from Uganda. So we try and understand, do the markets work in allocating fertilizer? A simple, broad, large, but important question. And if they do, if they don't, what are the reasons why they don't? And so just a quick preview of what we find. We find that when we measure the average returns of non-adopters of fertilizer, we see that the returns are too low to justify giving out fertilizer for free. But we do find that there are some groups of farmers that would benefit from some subsidies. But the size of the subsidy is about 30%. So quite lower than what is often adopted by a few governmental policies in African countries. And the fact that there exist some farmers who would benefit from subsidies then suggests, and who have high returns from the fertilizer, but potentially, but they are not realizing it, suggests that the market is not working efficiently. And we investigate to what extent liquidity constraints sort of are to blame for this lack of efficiency. Let me, I'm itching to talk to you about the experiment, because I think I'm really passionate about the design of the experiment. But before we do that, I think it would be very helpful to go through some very simple theory that both motivates the experiment and kind of also shows what we're measuring in the experiment, that I think is gonna allow for like a more complete understanding of what we're trying to do. So let's consider an investment good with an heterogeneous return, theta. How do we make sure that this investment gets made by the people with the highest returns? Mapping farmers over a space in which you have theta, which are just the raw returns. So by theta I mean just how much profit I make from getting the fertilizer, without subtracting the price of the fertilizer itself. And I'll plot theta over and y is the wealth, or like the liquid wealth that a farmer has. So here we have 4 farmers, farmers with higher returns, farmers with lower returns. Just confirming, are you able to see my cursor on the screen?
Not right now. Oh, I do.
But if you
Oh,
look
yes,
interesting,
yes.
okay. Thank you. So, some farmers with high theta, so with high returns, some farmers with low theta, so with low returns, some farmers with low wealth, some farmers with high wealth. What is this farmer's willingness to pay for the investment? Now, I'll plot the willingness to pay of these farmers in blue. In a market without liquidity constraints, this farmer, for example, as this return theta. So what is their willingness to pay would have to be would equate to theta. So they are willing to invest until the amount of their return, right? They are willing to invest. They're willing to pay a sum that's equivalent to the return that they get from the investment, very simply. This farmer here, their wealth Y is low, but they could borrow in a context in which there are no constraints, and so their willingness to pay for fertilizer or for an investment good in general, and fertilizer in the case of this paper, would be equal to the returns that they get from the investment, right? So this means that basically the willingness to pay for an investment will be equal to the return that an agent gets from the investment. Pretty straightforward. So this means that the average returns, conditional willingness to pay, are on the 45-degree line. And so that we can draw the distribution of willingness to pay that then we can integrate over to understand and estimate the demand for the investment good. In a context like this, in which there are no constraints, there are no liquidity constraints, how do markets allocate the investment? Well, there is a price, right? And what do prices do? Prices do have a selective effect over investment. So when there is a price, the farmers or the agents that will invest are those whose willingness to pay is larger than the price. And so that will mean that the willingness to pay, the markets have select the farmers with the highest returns. So in this case, the farmers that have returns above the price are the ones who invest. And only the projects that have returns larger than the price get invested in. And this is in a context in which there are no constraints, there are no liquidity constraints. But what happens when we introduce liquidity constraints? So when we introduce liquidity constraints, farmers or agents, they can't borrow, right? They don't have the liquidity to invest. So they would like to invest all the way up to theta here, up to the 45-degree line, but they are unable to. And so then their willingness to pay, here marked in orange, will be the minimum between their liquid wealth and the theta. Because they can at maximum invest the liquid wealth that they have in their pockets to purchase the investment. So then in this case, this farmer will be able to will have a willingness to pay that matches its return, because their return, because this farmer has a wealth that allows them to purchase the investment and matching their returns. So the result of this is that the average returns, conditional on willingness to pay, now will not be anymore on the 45-degree line. And there will be they will be higher, they will be above the 45-degree line in some bits. And this, when you match it to when you look at what does this mean for the distribution of willingness to pay, the distribution just shifts left. So the demand decreases because people are not willing to pay as much when they're constrained. So when we introduce a price, then the selection effect breaks down. So while in the unconstrained case, introducing like the price guarantees that the farmers with the highest returns are the ones who invest. In the constrained case, that's not anymore the case. And so you will have, you may have some, you will have some farmers that have high returns, but they cannot afford to make the investment because of their liquidity constraints. So in this case, what to do? Well, introducing a subsidy might be welfare increasing, because introducing a subsidy in this case, the optimal subsidy would be this PS marked with a gray line, a subsidy for farmers, such that the farmers that are induced to buy at the new price PS are the ones who have return equal to the market price of fertilizers. And so this generates a welfare gain. And we see that here, this shaded area are the farmers that are now induced to buy at the new price. And as I said, it's a welfare gain because the average returns of these farmers are positive. But of course, it's possible that that the optimal subsidy is zero. And notice how, if we were instead to introduce a subsidy in a context in which we don't have liquidity constraints, then a subsidy would make no sense, right? We would only generate a loss, because we would, a welfare loss, because we would induce to invest farmers that have a level of returns that is lower than the market price. So this picture again is just to show you how, in the unconstrained case, the distribution of the willingness to pay is expected to take a certain shape, while in the constrained case, the distribution shifts to the left. Now, the reason why I'm showing you this, besides rehearsing and going through some Econ 101 again together, is to really bring home the point that the quantities that we care here in the experiment today are really the willingness to pay for an investment of constrained and unconstrained people, and the returns to the investment of constrained and unconstrained people, just to bring home the points of, are markets working to allocate fertilizer, and if not, for whom are they not working, and how and what are the likely causes. I will, maybe in the interest of time, skip the contextualization with the literature, but let me maybe just make the reference. Like, I think the papers that are the most connected to ours, of course, we draw from the Duflo Kremer Robinson paper of 2011, showing that farmers in Kenya have high returns to fertilizer but low take up. And I will discuss, I think, a little bit more also later, that we are methodologically close to the work by Susanna Berkuver and Justine on, they look at the willingness to pay for fuel efficient stoves, and they see that farmers' willingness to pay for fuel efficient stoves is lower than the gains that they would have by using the fuel efficient stoves, in terms of money that they spend on charcoal and fuel. So then I will, let me move to the empirics. So the quantities, as I said, that we're interested in are willingness to pay of constrained and unconstrained farmers, and the returns to fertilizer of constrained and unconstrained farmers here. How do we measure willingness to pay? So we use, I don't know, and it'd be nice to hear from you how differently familiar people are with willingness to pay elicitation in the field. It's a big and interesting topic, and I've worked a little bit on this. What we use in this case is a variant of the BDM mechanism. The BDM mechanism stands for Becker, the Good Marshall. And the basic idea, just to quickly bring everybody on board, is that a participant expresses their maximum willingness to pay for an item, and then a random price is drawn by the researcher. If the willingness to pay is higher than the random price, then the participant can buy the item, paying the random price. If instead the willingness to pay is lower than the random price, just like when you are in a store, the participant cannot buy the item. And so we use a variant of this called the multiple price list. A multiple price list, imagine it like multiple take it or leave it, like a sequential take it or leave it offers. So we speak to farmers, we ask, would you be willing to pay 0 to get fertilizer, to get this specific fertilizer amount? If they say yes, then we continue and ask, would you be willing to pay 20 for this fertilizer? Would you be willing to pay 40 for this fertilizer? And so on. When they say yes, we continue and we increase, we go to the next price level. We have 11 possible prices. And so the moment in which farmers switch, so when they say, no, I'm not willing to pay for the fertilizer, that's how we define the maximum willingness to pay. So in this case, 120K, that's the maximum willingness to pay of this farmer. I'm going to pause here for a second because I realized that I did not pause between the theory and the empirics, and maybe I should have to ask if there are questions. Okay. Then maybe if there are no questions, I'll continue. I'll stop again in a couple of minutes. Just
sorry,
to...
Benedetta.
Yes.
I do have a question on this. I was paying attention to the theory, and I'm completely ignorant of this topic. So I would like to understand why liquidity constraint will shape your willingness to pay. Like, I agree that willingness to pay is what you will be willing to pay for something, and I understand why it is independent on wealth. But then why liquidity constraints will shape your willingness to pay?
Right. Because when in a situation in which that's a great point, and thank you for giving me the opportunity to clarify. So when a farmer is liquidity constrained, that means that basically they don't have enough cash to be able to purchase something, right? And so ideally, my willingness to pay in an unconstrained context is equal to the returns from that investment. But if I'm constrained, if I don't have enough liquidity, then I just cannot pay what I would ideally want to. So if a fertilizer gives me a return of, let's say, $500, so I would be willing to pay up to $500 for fertilizer, right? Because I would be willing to pay 100, 200, 300, 350, 390, up to 400, because I know that I'm going to get a return of 500, for example. But if I don't have the $500 with me, and if I can't borrow them because I'm constrained, then my maximum willingness to pay will necessarily have to be the cash that I have. So if I have $50, if I have $100, that the idea is that if I have that, if that's only the money that I have, then that's the maximum that I'm willing to pay. Does this help?
Yeah,
or maybe not.
Yeah. Sorry if this is very basic, but I was thinking like consumer theory for real goods, and maybe I'm confused, but normally we we conceive willingness to pay as a wish, like independently of my budget, I would be willing to pay this much for a good that I value a lot, right? And it is independent of my budget. If I don't have the budget to buy it, I just have a willingness to pay, but I cannot buy it. I am trying to understand this. Maybe in financial markets it is slightly different, but that is the point of view, my point of view. So I wanted to understand if, like, what is the intersection between these two? Like, yeah, the definition you're
Right.
giving in this case, and thank you.
Well, the let's see. So you agree that then like willingness to pay would be, it should be equal in an unconstrained world to the returns to the investment, right? And so you say this should be, independent. I have a willingness to pay independent from my wealth. I know that I should be willing to pay this amount for a return that for a certain return. So this is also partly the experimental question, right? That we have. Is willingness to pay affected by liquidity constraints? Because I can imagine in an unconstrained world in which I can just say, okay, then I will. This is a great investment. It will give me $1 million return. I just need to find up to $1 million to purchase this investment. But if I don't have it, if I can't and I cannot borrow it, which is the context in which we're going to be operating, then my willingness to pay will have to match the maximum amount that I can pay. And so all that thought, and let me walk you then, when we'll get to the results, I'll show you empirically what this means. And then we'll see if, like, hopefully I've convinced you about how this elicitation works and why willingness to pay is affected by liquidity constraints. That's a very important and fundamental question. So in this farmer, continuing with the example, as a willingness to pay of 120,000 Ugandan shillings. This is about $20. And then we give them, like, instead of sort of like the random price extraction of the general way in which BDM is done, we give participants scratch cards where the random price it has to be scratched off. So as you can see here, first the respondent writes their maximum willingness to pay on this card, then they scratch it and they reveal the price, the randomized price. And once again, a reminder that if this price is larger than 120,000, then the farmer cannot buy the fertilizer. But if this price is lower than the 120,000, then the farmer can buy the fertilizer. And so you may think, oh, this sounds like a complex field intervention. And so we did quite a few trials before doing the actual fertilizer willingness to pay elicitation. We elicited farmers' willingness to pay for a voucher. We elicited farmers' willingness to pay for soap. So we went through a lot of rounds so that farmers would be very comfortable with the willingness to pay elicitation. And in fact, this graph is taken from a paper that we published on the JDE using data from a pilot that we ran to run this experiment that I'm discussing today with you. And basically this shows, the fourth bar shows that the elicitation mechanisms that we used for this experiment had about a 90% comprehension rate. So when we assess comprehension rate, we could see that about 90% of the respondents were making optimal choices in their elicitation. So we are confident that farmers understood the exercise. The prices that farmers scratch, there are different ways in which prices can be distributed when one does a willingness to pay elicitation. In our case, it was our idea was to set prices, the randomized prices that farmers scratch over, as a almost binomial. So where basically by varied distribution. So where we would have either that prices are equal to 200 or the prices are equal to 0. So most of the farmers scratched either 200,000, which is the maximum price, or the 0 price, so got it for free. There were also some farmers that had intermediate prices. So specifically, the distribution of the prices was 45% had 0, 45% had the maximum 200, and 10% had intermediate prices. This this distribution is shaped in this way because we thought it would be very helpful for the following reason. So once that when you have either the maximum price or the zero price, what this allows you to do is that for every willingness to pay bin, so for every one of these bins that you see here to the left of willingness to pay, you have some farmers who get the fertilizer for free and some farmers who do not get it because it's 200,000. The price is 200,000. And so this means that we are able, for every willingness to pay bin, to layer a randomized fertilizer distribution with half of the farmers getting and half of the farmers not getting it. So that what you see here in orange. So for every willingness to pay bins, there are 11 bins, you will have half of them getting the fertilizer and half of them not getting the fertilizer. And then now the question, also going to the question that I had just before, about liquidity constraints. How do we relieve liquidity constraints? So before doing the whole elicitation that I've just told you about, there's something else we did. We ran a lottery. In these lotteries, some farmers got 5,000 Ugandan shillings, that's about $1. And some farmers, the lottery winners, got 200,000 shillings. 200,000 shillings is the price of the fertilizer, the market price of the fertilizer bundle that we sell in the willingness to pay elicitation. And so farmers that get the lottery tickets, getting them at 200,000 shillings price, have their liquidity constraints relieved because now they have their Y, so their liquid wealth is larger than the market price of fertilizer. So before then I move on to the next, maybe one interesting thing that I can say is that as part of, of this, so there are a few ideas that we had in the design of the experiment that I think were important for the success of this. So one is we distributed these lottery tickets at baseline. And so farmers, as sort of like a thank you gift, farmers had these lottery tickets and then they revealed whether it was a 5,000 or a 200,000 shillings lottery ticket that then got paid. So they received the money from the lottery 5 days before the willingness to pay elicitation. So this also makes sure that because everything is happening very close to each other in terms of time, farmers get the money. So the once they get the 200,000, they get it right before we go to their communities and elicit their willingness to pay for fertilizer. The second thing is you want to be very careful when you do elicitation of willingness to pay. You want to be very careful about the field protocol, right? If one reason why we wanted to pre-assign the price is that it's impossible to game that price because the price is printed on a piece of paper with the name of the farmers and they have to scratch it. So first, the fact that they have to scratch it really connects for the participants that whatever willingness to pay they tell us, that will not influence the price that they end up paying differently from a first price auction. So the price is predetermined and this is very believable. The second is that because we had the price, they had to write their willingness to pay on that card, as you see in the picture. Then we enumerators took a picture of that card and then they scratched it. And then enumerators again took a picture of the scratched price. It was not possible for the enumerators to, for example, draw another prize until that person wins the fertilizer. And so this ensures that there is like a sort of like a protocol that is airtight in terms of it's not possible to manipulate this protocol. I will now pause for a second. As I know that this may be a lot of new information, and then maybe there are questions about the willingness to pay elicitation or the lottery.
I have a question. I don't know if I miss it. Were they required to buy fertilizer with the price, with the money they receive?
No. So this is a very good question. We do not absolutely tie it. They get this windfall on their phone in terms of like a mobile money payment. And they just say that it's a lottery payment for the fact that they participated in the baseline survey. So it's not connected to having to buy the fertilizer in any way. Yes.
Good, thank you.
So I have a slightly related question. So I guess something that could be interesting to sort of assess whether your measure of willingness to pay is accurate will be to see if people actually buy the fertilizer when the price that the card shows is below the price they write. But then given that you have such high concentration on zero as a price, then that's not informative anymore. Is that something you thought about? Like,
so this is a very good point, and there are the compliance that we have. So remember that we still have we have a lot of zeros. We have 45% of people that draw zero, 45% that draw the maximum, and a 10% that draws intermediate prices. So maybe now it's very small, but it's this distribution that you would see here. These little bars. So we do two things to sort of like enforce the mechanism. The first is they have to sign a contract. If their willingness to pay is higher than the price, they sign a contract that says, you know, I will pay for the fertilizer. I will pay the price that I have scratched. Of course, this contract is difficult to enforce, but it's sort of like to have them see. And this was like thoroughly explained, you know, before in previous rounds as well, that it, sort of as a commitment device that like whatever price is scratched and they have to buy. Second, we sort of like keep in touch with them. So when we go to the villages, to the communities with the fertilizer and then they have to pay, we have almost perfect compliance. So
okay,
all the
that's very informative.
Yeah, but that's a good point. I think we should have it's for, I think the lack of compliance is among 4 farmers, so it's very little. But we should have that. I think also here in the slide. Good point. Perfect. So yeah, another thing that I want to say then, pausing on this for a second, is that I want to dwell for a second on why I think this mechanism is great for eliciting people's real willingness to pay. So this system, this mechanism is incentive compatible because farmers, you know, they cannot affect the final price, right? The price is pre-assigned, is predetermined, and it is in their best interest to express their true maximum willingness to pay, because if they said a willingness to pay that's higher or lower than their true willingness to pay, then they would either end up buying when they don't really value the fertilizer as much, or they would end up not buying when they value it more. An example, if my true willingness to pay is 100, but I say, oh, my willingness to pay is 80. If I then draw the price of 100, I will end up not buying because I said to the researcher that my willingness to pay was 80, but because my true willingness to pay was 100, so I would have been better off buying the fertilizer. Converse example, my true willingness to pay is 100, and I say that my willingness to pay to the researcher, I say it's 120. If the price is 120, then I may end up buying even though I at 120, even though I value at 100. And so I only make myself like the way that I make myself that I do myself in my best interest is by stating my true willingness to pay. So that's why this is incentive compatible. Are there any other questions? before I proceed with the settings?
Maybe not.
Okay. Awesome. So this research takes place in the eastern part of Uganda, this orange highlighted bit of Uganda. This is a country, this is Lake Victoria. The equator is sort of like passing at some point here. So it's a tropical, it's an equatorial area, it's a tropical area. This is at the border with Kenya, the orange highlighted area. And so some of them people who are familiar with the Duflo in our paper will remember that it's set in Western Kenya, so literally across the border from our experimental site. The type of fertilizer that we give out is DAP and CAN. For those of you who are interested, so DAP is a phosphate fertilizer and CAN is a nitrogen fertilizer. We give both. We give 2 bags, so we elicit willingness to pay, and then we provide 2 bags of 50 kilo each. One is a basal fertilizer, which means that it's to be applied when one plants, and the other one is a top dressing fertilizer, so it's to be applied when the plants are knee high. So they both work together, and the reason why we chose this, well, the can, of course, has very good evidence coming from Duflo, Kramer, and Robinson, but the packaged DAP and can is coming from us going around and asking different agro dealers for what is the fertilizer that they recommend for maize growers. This is sufficient to fertilize 1 acre of land, and the market price is 200,000. So that's why, you know, the maximum price that you have in the elicitation is 200,000. The lottery big price is 200,000. It's all targeted and crafted so that it matches the market price of the fertilizer that we provide. We did this experiment over 2 seasons, 2 years. In the first sort of season, the first part of the year, in 2017 and in 2018. The sample is a set of villages from the orange highlighted districts that I showed you here. So we, in order to select the sample, we took the census of all of the villages, all of the communities from the census, and we selected those that were had a certain population density below 100 households per square kilometers. Because we wanted to make sure that they're rural. And then we actually visited, we randomized a total of 153 villages, and then we visited them, and we interviewed all of the households in these 103 villages. We collected information about whether the households are basic information about the households that then we use to sort of screen them in. And these criteria were whether they're engaged in commercial farming, whether they have grown or plan to grow maize, whether they have a mobile phone with a mobile money, a phone with mobile money, and if they cultivate between 2 and 6 acres of land. So if you are like me, I had no idea what acres is because I think it's imperial units and I think in square meters. I don't think in imperial units. It's about, I think 4,000 square meters. It's kind of like as large as a football pitch, if you will. Maybe that's something that is more familiar to many of us. So 2 to 6 acres is, 2 to 6 sort of football pitches. It's not large. It's still smallholder farmers, but it's not sort of like the ultra poor. I just don't want you to think that these are like ultra poor, very constrained farmers. So out of these criteria are not very selective. It's very common in Uganda to, fulfill this criteria, are pretty common. And we ended up selecting about 1,200 households. So 400 in the first year that we did the experiment, and then 800 the second year that we did the experiment. So this is how this is their geographic distribution. You can see that the blue ones are the ones we did in 2017, and the orange are the ones we instead the households that we added in 2018, and these are pretty evenly geographically distributed in the area. As many of my colleagues doing agricultural economics know, collecting information in yields is really hard. Knowing from farmers how much farmers cultivated is complex and requires many strong efforts in data collection. So here I just want to show you some things that we did. So first, after we did the census and the baseline that I've mentioned, we made the lottery payouts 5 days before the willingness to pay, as I mentioned earlier. So we pay out the lotteries, then we go for willingness to pay elicitation. It was very important for us that the willingness to pay elicitation, and so that the fertilizer would reach farmers before the planting time, because one of the two fertilizers is a base fertilizer, so it needs to be applied at planting. And so as you can see here, we were pretty good at this. Not as much maybe in the first season. Still, most of the times we went to do a willingness to pay elicitation before farmers have planted, but we were really good at this in the second season, where we really went to do the willingness to pay elicitation before farmers had planted any maize. With respect to the estimation of yields, we do this in 2 ways. Actually, 3 ways. So first, we use farmer recall data, so just like a farmer follow-up survey. But then what was a bit more exciting, at least for me, was that we also did a crop survey and a cob survey. So the crop survey we did, I'm going to show you a picture because I love showing pictures of how this process went. So these enumerators are just put down on the floor a 1.5 times 1.5 meters wood quadrant. It's a large quadrant that they just like we have a randomization protocol. They put it on the floor in the plot, and then they count how many maize plants they can see in this quadrant. And we also did a cob survey where within some selected randomized quadrants, they would harvest the cob, of course, compensate the farmers for the cobs that they have harvested. And then we would measure their fresh weight and then their dry weight in order to allow us to make high quality conversions of them of our harvest estimate. What we end up using in the results that I'm going to show are sort of like an average between farmer recall data and the measures that we obtained doing this quadrant technique. And then you can see, like, from the baseline that took place in January. So this is for the first year in 2017. Then we had sort of like follow up in August. So this is pretty, we go there at the end of the season once all farmers have had the opportunity to harvest their crops. And then we collect some more information just on the phone a little bit later. I am now gonna move on to the results section, but maybe I will pause here another second and give you some space for questions. Maybe, okay. If there are no questions, I'll continue. Otherwise, I trust, right, Corellis, that people will just unmute themselves. Hopefully, I haven't confused you completely.
No, we are waiting for the results.
It's like either one or the other, either completely confused or it's too clear. Okay, so I opened this seminar with telling you what's interesting for us is measuring willingness to pay of constrained and unconstrained farmers and returns to fertilizer by willingness to pay bin. And so let me start by showing you how much farmers are willing to pay for the fertilizer. So this is for the lottery losers. So this is the constrained group. You see that most farmers are willing to pay actually about 20,000 shillings for the fertilizer. That's a tenth of the price. And what's interesting for us is that there's about 4% of the farmers that actually are willing to pay the market price of fertilizer. And the reason why this is exciting for us is that this matches very closely the rate of investment that we see in fertilizer at baseline. You will see that about 4% invest in DAP and 2% invest in CAN. And so having this number sort of nicely square up for us was encouraging, because it means, you know, this is a good measure. It's a further confirmation that this measure works, and it's a good measure. The average willingness to pay for fertilizer is about 56,000 shillings among the constrained farmers. So then let's move on to the unconstrained farmers. So farmers that have received a lottery payout of 200,000 shillings 5 days before the willingness to pay elicitation. So what we see is, just as we saw in the theory, that the willingness to pay distribution shifts to the right when farmers are unconstrained. So farmers, maybe the largest bin was the 20,000 bin that the constrained farmers were willing to pay for fertilizer. You see a big drop, and you see that basically there's a movement from the 0, 20, and 40 bin into the higher beans. So basically all of the other beans, 60, 80 until 100, see that experience that there's an increase. And this is due to the farmers who won the lottery are more likely to shift their willingness to pay to the right and report higher prices. So this is what we were discussing earlier. And hopefully I've convinced you that in an elicitation, in a willingness to pay elicitations that has real stakes, so in which farmers have to express their willingness to pay, and then they are incentivized to reveal their true willingness to pay through a purchasing exercise, we see that a willingness to pay is affected by liquidity constraints. And so we see that with liquidity constraints, the demand curve is to the left of the unconstrained curve. The willingness to pay,
excuse me, Benedetta, I think we have a
Yes.
question, Juan Esteban.
Yeah.
Yes, just a very quick question, Benedetta. Are these willingness to pay, these measures weighted by the characteristics of the household or something? I mean, I don't know whether I'm missing something, but I would have expected way more, a much bigger shift to the right, considering that if the counterfactual is the orange distribution, then those people with a willingness to pay of 20 should have shifted all the way to the right. I mean, if that was if liquidity was the only constraint inhibiting them from purchasing fertilizer, it is very weird that the shift is so small.
Yeah, I see your point. I take your point. And also, you know, there are reasons why willingness to pay can be different from, you know, like the expected returns. Partly these may just match whatever they believe that the returns from fertilizer are, and so that's why it moves a little bit. It doesn't move too much. Partly it could be that farmers do not know what their actual what the returns are from fertilizer, so it might be that willingness to pay is different from the theta, if you will, because of that, or there may be you know, they may be exposed to an insurable risk. And so there are definitely other reasons besides just sheer liquidity constraints why willingness to pay for fertilizer may be low. Absolutely. And I don't want to claim that that's the only reason. The average willingness to pay, so with the cash lottery, for the cash lottery winner, shifts to the right of about 70 to about 72,000 shillings. So so it's a little bit more of like a 15,000 shillings shift to the right.
And is that statistically significant?
Highly statistically significant. It's one of those cases in which I remember that the inference randomization inference p-value was the smallest I've ever seen in any of my papers. Yeah. And so then let me move on to the average treatment effects. So like basically we move on now to answer the question, is it in general profitable for farmers to invest in fertilizer? So the estimate strategy that we adopt here is a one in which we can estimate within each bin. So within the blue and the orange bin, we can estimate what are the profits, the raw profits from fertilizer. And so we can compare the people who got, people who got the fertilizer and who didn't in each one of these bars. So in the blue bar and in the orange bar, we can tell, we can disentangle whether they got the fertilizer or not. And so our objective then is to understand the returns from winning the fertilizer or from not winning the fertilizer, and from then just having your liquidity constraints relieved. All of these estimates will include village fixed effects, baseline farm size, and baseline maize output. And will not include the intermediate observations. And this is definitely something we can discuss later on why we made this choice. What you then can see here, actually, let me just show you the table. So the first row is the returns to fertilizer among the constrained farmers. The second one is the returns to fertilizer of the unconstrained farmers. And the third one only tells us what's the impact of relieving liquidity constraints. So I first want to show you through, walk you through what happens physically in the field, right, to these plants. So in squared brackets, you see randomization inference p-values. And in round brackets, you see the standard errors. The first column tells us the number of maize plants that the enumerators can count in the quadrants that I showed you earlier increases. So from 5.2 in control, for those farmers who get the fertilizers, similarly, we observe 0.5 more plants. Expectations is the enumerator assessment of basically how good these plants look, if I were to put it very simply. And so enumerators are asked to make an assessment, of like whether compared to like a healthy harvest, whether these plants look, like they would yield 50% of a healthy harvest, 75% of a healthy harvest, 100%, 120% of a healthy harvest. And so we see that the expectations for the plants among farmers who get the fertilizer increase. So farmers believe, enumerators believe that these plants are looking better in the field. And so multiplying the number of maize plants time expectations basically gives us the plants that are expected to survive by the end of the season and provide a cob. We see that this also increases quite substantially by almost one extra plant. And so from a baseline of 3.4, which is a pretty large impact. Now, what's interesting is that you also see that these are dummies for whether the field is intercropped and whether there is line sowing. So what we see here is that there are significant decreases in the fields that are intercropped, and there is some increase among fields that are maize fields that are planted in line. So we interpret this as evidence that farmers are intensifying their cultivation of maize because they are, planting only maize. So a reduction in intercropped crop means that they're planting only maize. They're not intercropping it anymore, or they're intercropping to a lower extent, and they're planting in lines. This is also partly coming from the fact that it's less labor intensive to apply top dressing fertilizer when plants are planted in line. Because I showed you also how the picture from the field, how the plots look, and so they're planting in line definitely makes it easier to walk through them. So this is on the sort of physical aspect of the plot. So we see that things are looking quite a bit better in terms of the plants that we see and the expected harvests that enumerators estimate in these fields. Now, what happens to profits? So here we show you different measures of profits, also because in the literature there is different papers present them pretty differently. So we wanted to be exhaustive, but also because we believe it's very interesting. So the maize revenues from getting the fertilizer, so this is without subtracting the price of fertilizer, are in the neighborhood of 130, 140, 120 to 140 for lottery losers and lottery winners. So the maize revenues by themselves are sort of like lower than the market price of fertilizer. And then from these maize, from the raw maize revenue, we subtract the value of the fertilizer that they may have stored, because we gave them fertilizer, but they didn't use necessarily all of it, so we subtracted value. Then we also subtract the value of the non-labor costs, which can be seeds, which can be other inputs. Then we subtract also the value of hired labor, because in our survey we asked them if they hired external laborers and how much they paid them. So we are able to also take that into account. And we also subtract the value of family labor. And this is pricing family labor is not an easy exercise. Here, what we use is the estimates provided by in the Agnes and Coulter's paper by Pascaline and Dupas and Coulter, where they estimate that the price, the wage value of the self-employed is about 60% of the going wage. And so we apply that. We value household labor at 60%, following that paper, at 60% of the going wage in these communities. So after we've done this exercise, what we can see is that really the returns are between 70 and 30,000 shillings. So we conclude that it is definitely not a good idea to hand out fertilizer for free, because on average returns are too low to justify giving it out for free. If interested, we can go through the table if you'd like to look at the individual coefficients. But I think maybe in the interest of time, we can go back to that later. One result that I've added recently to this, because also we were talking earlier with Karelis about the value of soil quality and how heterogeneous soil conditions are really important. And so we don't necessarily really have like a good sample to look at the heterogeneity across soil types. But what I can tell you is that the average returns look pretty different if we consider soils that are acidic, so where the pH is lower than 5.5, and soils that are less acidic, where the pH is larger than 5.5. we have this measure comes from a baseline measurement of the soil pH that we don't have for all of the soils. We were just able to do this for a subset of the soils, and the number of plots that we have that have a pH above 5.5 is about 20, around 20%. So it's little. This is a small sample. So I just want to, let you know, I think this is very interesting, but this is also really coming from a small subset of the plots that have less acidic soil.
Benedetta, excuse me, we have a question from Margarita.
Yes, Margarita.
Quick question. So, do you also observe this heterogeneity in the changes in the willingness to pay based on soil characteristics?
Very good point. We checked. I was convinced we would. We don't. Farmers with more or less acidic soils do not have differential willingness to pay.
Oh, okay.
So
Okay.
this, my takeaway from this, and I would like to do more research on this, is that it's pretty hard to know if your soil is acidic or not. We know because we did lab tests. These were tests that we brought with us, were not necessarily locally available to test the pH. So it's just very hard to know because it's not necessarily an observable characteristic. So definitely, I think something that's very interesting to keep researching on, and more research is coming up about this. I wish we could say more. I wish we had a larger sample of less acidic soils to draw more meaningful conclusions, because you do see that instead returns on average look much higher for the farmers that have less acidic soil. So this is an indication. This is a suggestion that this type of fertilizer will work better with less acidic soil. And once again, we chose this fertilizer because that was the going recommendation for coming from agro dealers, and also official recommendation from the government. So we have 15 minutes left, I think, top. So then let me just give you another couple of results so that we have some time also for questions later. You may be interested now in the marginal the marginal results, right? Because now I've showed you on average what happens, but you know that we have these results disentangled by willingness to pay bin. Because this is the interesting feature of this is that this is a selective trial where we can observe willingness to pay, so sort of like shadow effort from participants. So skipping over the costs, I want to first tie the bow on a quick comparison with the average treatment effect that we find compared to other papers. I think it's interesting. So Duflo, Kremer, and Robinson find about under 36% gross returns for CAN only, and this is higher than what we observed, because with a comparable output measure for DAP and CAN, we find 60 or 70% return. But when we adopt the measure that I discussed with you on what we believe is an appropriate profit measure, the returns are about 15 to 30%. And so, because these calculations, of course, do not include the price of fertilizer, then that's how we draw the conclusion that on average, fertilizer should not be given out for free. And then the average treatment effects of the lottery. So why don't we just give people cash? That's another question that we often get. And so we are able to look at that, right? Because we have a group of farmers that did not get the fertilizer and just won the lottery. So when farmers only win the cash, we observe returns ranging from 62,000 to 80,000 shillings. And so these are lower than farmers that get the lottery and the fertilizer. So you can see across the profit measures, they change a little bit, but in terms of the maize revenue, they're like a little bit more than half. And so the lottery giving farmers cash is also pretty effective. at increasing maize revenues and profits. And what we can see is that compared to similar papers that have provided just a cash grant, the impacts that we find are larger. So in Ghana, Carlin and Cotters give a $420 grant, and they find profits that increase by $65. So in relative terms, compared to what we find, these are lower. And Beeman and Cotters, with a recently published paper on Econometrica, they find that the impacts of a $140 grant in Mali increases profits, so gross profits. They do not sort of like do all of the calculation of labor costs and other unpaid labor, increases gross profits by $39. So also a little bit lower than what we find. Moving on to the marginal treatment effects. So these results are noisy. I am not gonna, claim that these are not. And you can see it by yourself. The distribution of farmers that are in the high beans is pretty low. We have quite some farmers in the low willingness to pay beans, quite few farmers in the high willingness to pay beans. So we can do this exercise. These are just the raw returns. These are just the point estimates. We can also calculate this by binning them. So grouping this in 4 beans of similar size or smoothing them linearly. But I just want to discuss the raw estimates in this case with you. And basically what we see is that there is a group of farmers that seems to have high returns. So positive high returns. And these are the farmers that have the constrained farmers with larger or equal to 140,000 shillings willingness to pay. So these farmers are farmers for which we can, we can plot basically what are the average returns of the induced buyers at different subsidy levels. So basically then what I want to show you here is that so those farmers that have more than 140,000 or more willingness to pay for fertilizer, they have average returns. So this group has average returns of about 300,000 shillings. This is 100,000 shillings more than the price of fertilizer. So these are high returns and they have high willingness to pay. And these are definitely farmers that it would be optimal to subsidize, which means that for us, in this case, the optimal subsidy is a subsidy of about 60,000 Ugandan shillings, so about 30%. And because the subsidy would encourage the farmers here that have under 40,000 or more willingness to pay to buy. And these are not many farmers. These are about 7%. And so a subsidy of 60,000 Ugandan shillings or 70 or 30% would induce 7% of the sample, these farmers here to the right, to purchase. But this is the case for the orange group. So these are the constrained farmers. When we look at the unconstrained, so the blue line, we see that relieving farmers' liquidity constraints causes them to increase their willingness to pay, and so moves them to the right of the distribution to the extent that now that their constraints are relieved, it is not optimal to subsidize them. So the optimal subsidy in the unconstrained group is 0. We do not want to subsidize farmers that are unconstrained. So then, I think the overall takeaway from this work, and as I mentioned earlier, I think it's it's pretty clear from the information that I presented thus far that on average, it is not a good idea to hand out fertilizer. It also does not seem to be a good idea to provide large subsidies on the fertilizer, because there is a group for which we see high returns, and this is a group that also has pretty high willingness to pay, and as returns that imply that they would be induced to buy with a 30% subsidy. And so those are the farmers that would benefit, inducing more farmers to buy. So moving the subsidy to more than 60,000 would crowd in farmers whose returns are negative. And so for whom it's definitely not a good idea to provide a subsidy.
Juan Esteban, you have a question? Yeah. Excuse me, Benedetta.
Yes, thank you. Just a very quick question. Was there anything special about that particular season? And the reason I ask is I still wonder why so many people bought the fertilizer with a lottery instead of just, I don't know, spending it. Given that exposed, it didn't make much sense. And I wonder whether that season was, I don't know, bad or something.
This is a good point. So, it is tricky. There are many margins that one can analyze to decide whether a season is bad or not. I have a graph here that's showing the average precipitation by calendar month. In season, like the grayed out area is the 30-year average. And then here in orange, you have season 2, and in black, you have season 1. So the black is 2017, and the orange is 2018. And so what we see is that these two do not seem to be large deviations from the long-term mean in terms of rain, yeah. And so basically the growing season for this would be around this period. So it's between April, May, and June, and this is when there is the harvest. Like after June, there is a harvest, and so this to us does not look like particularly extraordinary weather patterns.
Yeah. What about maize? Do they take the prices from like the commodity price, or is it like a very local market?
This is a good question. So we have different ways of estimating prices, and the prices that we are getting, that I am valuing maize revenues thus far, are prices that I take from the local 5 villages that are around each community. So basically, these are smoothed prices by regional, by area, but nothing changes if I instead take the village level prices, or if I take just one unique price. Because this is an interesting point, because Duflo Kremer Robinson, instead, for their Kenya paper, they just use one unique price, and they value all the maize using one unique price. We did both, and the changes are very negligible. But we collected price. Sorry, I should have said that. We collected price data with a market survey while we were doing this, right after the crop assessment, so during the harvest season. Finally, I will then close with some long run results. So I mean, long run is maybe a big word, because these are 2-3 months after the harvest. But these are alpha year agricultural seasons. And so what we can observe in terms of long run adoption is the following. So this is the same table, where again, in the first line, you have farmers who got the fertilizer but lost the lottery, farmers who got the fertilizer and won the lottery, and just lottery winners. And what you can see is that the chance of using fertilizer in the following seasons after the season in which we give them fertilizer increases. So from a baseline of 10%, we have 40% in the lottery lost being a group that adopt fertilizer in the following season, and about 41% of them that among those who won the lottery. So there are persistent effects of using the fertilizer. This is any chemical fertilizer, and these are only dummies for DAP and use of DAP and CAN. We see that they're pretty similar. We find increases and persistent increases in the use of fertilizer. And this is only partly driven by the fact that they have some leftover fertilizer from the one we gave them. So this is definitely happening. They have some leftover, but it does not only explain. It only explains about half of the actual persistence in adoption that we find. And the last thing I wanted to tell you about is that we believe these are learning effects rather than income effects. And why do we believe that? Because if you look at the lottery won, farmers who only won the lottery, we don't really see persistent fertilizer adoption. And so this tells us that, it's not really driven by an income effect, but rather suggests that farmers are learning from the use of fertilizer that they did in the experimental season. And so with this, I'll conclude. Besides, the point earlier of not a good idea to hand out fertilizer for free, and if any, a subsidy should be about 30%. And our conclusion is that this is partly the markets don't work efficiently for everybody, that there is a group of farmers. Unfortunately, there is a group of farmers with high returns who are kept out of the market, even though they have high willingness to pay. Their willingness to pay is not high enough to purchase the fertilizer at the market price. But and these farmers would be induced to buy fertilizer, and so would realize high returns if there was a 30% subsidy. We find that in the long run, using fertilizer for a season has persistent effect that seem to be driven by farmers learning about fertilizer returns. So this sort of concludes what I wanted to say today. Thank you so much for having me, and thank you for your questions.
Thank you so much, Benedetta. I don't know if there are remaining questions from the audience. I think this will be the moment to ask or comments. I was wondering if you had the chance to explore about this result that says that it's not like a good strategy to hand out for free the fertilizer, because you will think that since the main concern here are the liquidity constraints, you may think that if you hand out for free this fertilizer, this will free resources such that the farmers can take care of other items necessary for their production. So I don't know if you have had the chance to explore why this is the case.
Yeah, so our experiment does not allow us to look at, in isolation, the return, for example, from seeds. But one thing that we see is that, let me see if I can find it here. So what we see as a result of getting the fertilizer, that farmers invest a little bit more in non-household labor and household labor, and a little bit more in seeds. So one thing that I would be interested in would be, horse racing, comparing the returns of fertilizers to the returns of seeds, and understanding whether instead, it is a better idea to subsidize improved seeds for example. One big up, if you will, of items that are not fertilizer is that fertilizer can be quite labor intensive, and we can see it here, right? We can see that labor costs increase. So there are some complementary investments needed from farmers to apply the fertilizer, both when they're planting and when the plants are knee high. And so it would be interesting to understand if there are instead other farm inputs that would be a better idea to subsidize, that maybe have lower labor demands, such as seeds.
And I don't know if you also analyze or had information about what is the extension, or how constrained are the constrained farmers? Like, is that they don't have enough to, I don't know, cover the normal or average plot that they normally plant, or if you just have information constrained, no constrained, unconstrained. Is there any information about the extension of that constraints?
Yeah, so this leads me to something. I think we have a very, like a measure that we believe is a very good predictor of basically how much cash they have on hand. So we know how much cash they have, how much savings they have, and their assets, because we collect this information during our surveys. And we see that a good sort of measure, like indicators, so like a synthesis indicator, or whether they are constrained, if you will, they're poor or not, is when you ask them the question whether they would be able, in the case of an emergency, to find 300,000 shillings, whether they would be able to manage or not. And we do definitely see that this is a good predictor of actual resources that they have. Now, one thing that we could do is, I don't have this right now, but it's a good point that we could also look at the heterogeneity by this variable, and see how investment decisions are different in the sort of like constrained group, in the constrained group, among those who are maybe wealthier and maybe poorer. Yeah.
And maybe one last question that I have will be about your first result. This one that, if I understood correctly, those farmers that won the lottery and therefore are less constrained, their willingness to pay increase, right? If I understood correctly, that was the result. Are we completely sure this goes through just winning the lottery? I'm just thinking about, I don't know how you, gather this group of farmers, maybe tell them about the experiment. They know it is about the willingness to pay. So I just wonder if, just in the information the team provided for them, there was something that could affect their willingness to pay different than winning that lottery.
I see. So these results are driven by the lottery, in terms of the fact that these are people who 5 days before we went there, either got on their phone 5,000 shillings or got on their phone 200,000. So the information whether they won the money 5 or 200 is extremely private. Like, we don't. There is no way that other people will know unless they tell them. And so then we went to these farmers. Like, this was done at their home. The willingness to pay elicitation was done at their home. This exercise takes about an hour, and is done at their home. So it's also to guarantee that they are free, sort of like, to make their own decision. There is no I don't see that there would be possible to sort of socially influence the willingness to pay elicitation exercise in this context, as we took some sort of safeguards to make sure that anything that the participants were exposed to was private.
Well, Benedetta, I would love to keep talking to you, but I think we have abuse of your time today. And we are very thankful that you presented this result for us, and we hope to keep in touch and maybe that we can collaborate sometime in the future.
Yeah, absolutely. It would be my pleasure to talking again. Thank you so much for your attention. Thank you so much for your questions and for your feedback. It's really appreciated as we try and do some further efforts to prepare this paper for submission. Thanks so much.
Thank you.
Thank you. Bye bye.
Bye, Benedetta.